the air. So carbon dioxide, if it is present in the atmosphere, converts the light energy into heat energy that is responsible for warming. And because of the continued increase in concentration of carbon dioxide in the atmosphere, it is warming and consequently leads to what we call it as a climate change. And currently it is happening very fast than what happened before. So we are living in the age of climate change world. And this consisting of, we are witnessing extreme weather events like excess rain, ultimately leading to flood, storms, and not only this rain-related issues, and also we have heat-related issues. Heat waves in the summers are very, very hot nowadays. The minimum temperature at night is going up. Similarly, the maximum temperature day-to-day what we observe is also going up. Because of these changes with the excess rainfall and heat waves, ultimately that is leading to a lot of disease. Even what we met, the pandemic of COVID-19 is also one of the results of this change in climate change. And the main culprit we look at for the global warming and the consequent climate change is a carbon dioxide molecule. And if you see, this is really a naturally occurring gas, and that is also a byproduct of combustion of fusel material. Any organic matter, if you burn it, the ultimate product is carbon dioxide, maybe biomass, other or fossil fuels, whatever it is, that ultimately leads to carbon dioxide. And this carbon dioxide is a main culprit and major species, chemical species responsible for the global warming. About 60%, the contribution is from carbon dioxide coming from various sources. And because of the main reason, carbon dioxide is taken as a reference gas, and other gases like methane, nitrous oxide, or SF6 all compared to this, and the global warming potential of carbon dioxide is given as 1. And many countries nowadays paying attention to control the emission of carbon dioxide because it is the main culprit. And the US EPA, they have a limit. If any particular industry, any particular source, if it exceeds 25,000 tons per year, then you should go for carbon dioxide control. This is a limit. As we have when for CO2, NOx, particulate matter, earlier they introduced solution that is not very strict. If you see this various sources of carbon dioxide, and you can see the blue color, this is a thermal electricity production. Thermal energy is the main culprit. Even other industries, like if you look at it, cement industry, steel industry, everything, they also pick up the burning of fuel. Only ultimately, everything comes out from the industry. And thermal power station is a major one, using coal or other fossil fuels for production of energy. And if you look at all these sources, one of the main thing is all stationary, not like automobile, bus, car, or two-wheelers, and everything stationary source. This is the main thing, and we have a potential to capture the carbon dioxide and use it. And there are some estimate how the emission of carbon dioxide is going to be. Currently, it's about 2 billion tons of carbon dioxide is emitted from thermal power station alone per year. Okay. And putting all the sources, remaining sources, in 2020, at the end of this year, the carbon dioxide emission may be between 29 to 44 gigatons of carbon dioxide. Or in terms of carbon, it may be from 8 to 12 gigatons of carbon dioxide in 2020, this year end. It varies. There is a range is given. It depends on various mitigation options. And similarly, the prediction in the middle of the century, by 2050, the carbon emission may be from 6 to 23 gigatons of carbon as carbon. Carbon dioxide may be put into the atmosphere. So if you look at these numbers, it's very, very huge. Carbon dioxide is put into the atmosphere as an open dump. And this is mainly responsible for this global warming and ultimately resulting to climate change. So as a chemist or other people who are interested in this as a mitigation option, carbon dioxide, it provides huge opportunities. Okay? And there are various ways this carbon dioxide may be converted into a useful resource. Okay? So that is what my talk will be. And it is also at the same time, it is not very easy. There are some challenges also in converting this carbon dioxide into the useful carbon-based material. That is what we are going to look at it with a few examples. Okay. So right now, what globally people are doing to manage this carbon dioxide, okay? That is what we call it as a carbon dioxide mitigation. And the climate change issue can be managed two ways. One is mitigation, that is controlling the carbon dioxide main culprit. The other one is adaptation. Whatever the prevailing situation, we have to adapt to the situation and manage. So these are the two ways, but mitigation, that is preventing at the beginning itself. So there are various ways globally people are making attempts to minimize the emission of carbon dioxide, thereby mitigating the carbon emission into the atmosphere. There are various technologies have come. One is that is use fuel with a reduced carbon intensity, going for renewable energy like a solar, wind, etc., or nuclear. That is also okay. Or natural gas, which is considered as a carbon neutral. Biodiesel, all this thing comes as a carbon neutral because it can be grown as a tree, harvested again, and used as a recycle. That way, the natural gas also considered carbon low intensity because of the neutral thing. And also people are making attempts to mitigate the emission of carbon dioxide by putting more efficient technologies, okay, on both energy demand and supply side, including transmission, improvement in the efficient transmission of power without loss in this. That is also will minimize the emission of carbon dioxide. Okay. And if you really look at it, the renewable and nuclear, it's a non-carbon source. Okay. There is no carbon in it. It's all considered as a very environmentally benign technique. But we have another 30 to 40 years, the fossil fuel is left with us. Okay. So at the same time, we cannot close all the thermal power station also overnight. We are going to have thermal power station also another 30 to 40 years. So carbon dioxide is going to come out from this stationary source. So what we can do is, we can capture this carbon dioxide and store it underground without harming anything. And this is called popularly CCS, carbon capture and storage underground. Okay? And also, this includes increasing the forest cover. Okay? This is what globally people are attempting nowadays. Even Government of India committed to United Nations, that is as per the IPCC requirement, they will increase the forest cover. That is natural way we are going to manage the carbon dioxide, what we put into the atmosphere. If you look at the clean energy sources in which no emission of carbon dioxide, okay, definitely this is what the society all look for, which are all low carbon energy intensive, and mainly focus is on renewable energy like solar, wind energy, including hydro, all these things. And wherever possible, it should be definitely, it should be encouraged. Even Government of India committed to the United Nations by 2030, that is another 10 years now, they will go for manufacturing about 175 gigawatts of renewable energy. That is slowly we will shift towards the solar and other things. And solar is the main focus. About 100 gigawatts of energy will be generated through this renewable energy technologies. And also, there should be new technologies for energy storage and to solar to reduce the pollution. Okay? Even the energy storage is one of the critical issues. Whatever energy generated should be stored and transmitted for requirement. So strategies and initiative that reduce energy consumption also part of this clean energy program, and definitely the emission of minimizing the greenhouse gas emission in this also be what we live and work. That is our attitude towards the green gases also should be changed. Also, the clean energy concept focus on create effective solution. That is ideas, innovation in energy generation, and new discovery that will serve as indispensable elements in combating the climate threat. That is a shift from conventional energy to renewable or clean energy source. This is what considered to be a clean energy source, and a lot of potential is there in many countries as shifting slowly towards this. And if you look at the renewable energy and solar mission in Government of India, and including Tamil Nadu, we are focusing a lot on this, especially solar, wind energy, etc. as focus of this one, including hydro. Apart from this, if we consider the carbon from the conventional source, one of the main thing is carbon sequestration and storage. This is what globally many people are started attending, especially European Union is paying a lot of attention. And this can be managed in different ways, that is naturally. Through photosynthesis, I hope all of it's a school things we have learned. Carbon dioxide will be the raw material for photosynthesis and the new plants material. So this can be addressed naturally without anything, naturally in a terrestrial ecosystem. So that is what Government of India also, especially educational institute, one student, one tree concept is part of this solution. That is carbon sequestration in the atmosphere through natural way. Fine, this is alone will not solve the issue. Definitely, it is a part of the solution. Huge amount of carbon dioxide can be sequestered naturally through increasing the green cover. At the same time, whatever we emit cannot be managed with this alone. We should go for other alternate, that is an engineered system to speed up the process, and algal pond is another way, geological storage and ocean storage. These are the other options available in engineered system. I have learned through the organizer, some of the participants are from biotechnology background and geology background also. And this is one of the ideal options, especially for biotechnologists through natural photosynthesis and engineered system using algal pond is the way through which biotechnologists can focus on doing their contribution through mitigation of carbon dioxide. And if we look at geological storage and ocean storage, geologists can play a major role. Whatever the mines, abandoned mines or rocks, etc., is the ideal one for storing carbon dioxide. Okay? Because we all know carbon dioxide, only if it is in the atmosphere, it is a problematic. Suppose if it is stored in the other form, definitely no issue. So geologists can pay attention through geological means and the ocean storage. And chemists, I understand most of the participants from chemistry background, and they have to pay attention through what is called, instead of storage, utilization. Carbon dioxide utilization is a key focus. Okay? The algal pond also is a part of this solution on carbon dioxide utilization. And in fact, this is part of the sustainable development, the climate action, and the agenda out of the 17 sustainable development goals, and the goal number 13 is part of this climate change mitigation. And also, whatever we produce, responsible consumption and production is also goes with this, especially energy sector. Conservation of energy is a key. Okay? So that is what responsible consumption and also production of energy is a key in which we can minimize carbon dioxide. And this is also called carbon economy, circular carbon economy. That is again part of the sustainable development. We will see some of this concept of this circular carbon economy. And really, it is not only for this carbon. The circular economy as a concept focus at system at eliminating the waste and the continued use of the resources. So the circular economy concept, any industry produce waste that is not considered as a waste. You have to look for the resource present in this, okay, and continue to use the resource from the base material. That concept is called circular economy. And in this condition, whatever the thermal power plant or steel, where we burn and liberate huge amount of carbon dioxide, is considered as a resource here. Okay. So carbon dioxide is not a waste. You consider it as a resource and try to capture and use it in a beneficial way. This is called circular carbon economy, and which is in contrast to the linear economy. Okay. And this is in contrast to the circular economy. And the linear economy, normally the system focus on take, make use of it, and dispose the waste. This is a model of production of linear economy, which is not a good concept. Because the circular economy system approach is to economic development, definitely it is a resource material, and also is going to benefit the business, society, and hugely the environment. Okay, we are going to benefit from this because the main crisis, climate crisis, is avoided because of this reutilization of carbon dioxide. So that's a reuse concept is played huge attention in the carbon economy. And this slide shows the linear resource economy in which waste material is not focused. Waste is thrown out, that is disposed. Whereas in the circular economy, you can see that the recycling arrow, it is very, very thick. Whereas in the linear economy, very, very small one. And you see this one, the disposal and incineration in the circular economy is lean, very small one. Whereas in the linear one, it is a big one. The disposal, the waste is big. That makes you the difference between the linear one and circular economy. So the sustainable concept focus on this circular resource, including the carbon dioxide. And this main carbon circular economy or anything in the circular one, there are the 4R concept is a backbone of this. Okay? That is reduce, reuse, recycle, or remove is a concept. Okay? So this 4R, not only for this carbon dioxide, any system or industrial operation, any waste come, you have to pay attention, focusing on this R concept so that no waste ultimately goes. So specifically for this, that is reducing, use in all carbon mitigation options and fuels with a reduced carbon footprint. Okay. So carbon mitigation through this reduction of this emission of carbon dioxide, reuse, that is carbon capture and utilization without chemically altering the carbon. Just in the same form, whatever carbon dioxide comes, try to capture it in a pure form and use the carbon dioxide as straight. That's called reuse. In the case of recycled carbon dioxide, that is create new value and add products by chemically altering carbon. That is, the carbon dioxide is converted into value-added products with the carbon. That is what a recycle. And remove, that is carbon capture, utilization, and storage, including direct air capture. All these things comes in this, and that can be through natural sinks. There is a green cover increase, remove the residual carbon dioxide through natural means. So this 4R concept is very, very key for this circular carbon economy. Coming to the reduce option, okay, that is, it represents all carbon mitigation options that reduce the amount of carbon entering the atmosphere. Okay. And in this direction, a lot of huge efforts towards energy efficiency through new technology, policies, and solutions that lead to reduced energy consumption. And because of this, the associated carbon emission into atmosphere also minimized. this is part of the reduction of carbon dioxide into atmosphere. Also, reduction can also include increased adaptation fuel types that have no carbon footprint, such as nuclear energy, in which uranium, thorium are burned and we get nuclear energy. And also fuel switching from coal to natural gas, that also makes this carbon as a neutral. And also there are opportunities, apart from this carbon, we have hydrogen, okay, that also can be produced from natural gas via steam reforming in this one way. That is carbon dioxide utilization also possible with the hydrogen production from this. So that we have various options of producing hydrogen, including biohydrogen, going for other energy source that is apart from renewable, that's a nuclear energy also. Okay. And multiple sector which can potentially achieve multi-sector decarbonization also important, okay, in this reduction. Coming to reuse, that is carbon dioxide is not reacted chemically, and from the source where it is there, it is isolated, separated almost near close to tube form, and then the carbon dioxide is used directly for various beneficial purposes. And two important applications is, one is especially for the faculty members from Zoology department, enhanced oil recovery and enhanced gas recovery. Okay? So these are the two options. Already many places this is going on. The carbon dioxide is captured from the stationary source, and in the oil field and gas field, the carbon dioxide is pumped inside to get enhanced recovery of oil and gas, and this is what the main way of managing or reusing the carbon dioxide, because carbon dioxide goes underground and stays there, whereas we get oil and gas instead of carbon dioxide. This is one of the reuse options possible. And many things also, direct use of carbon dioxide also, a few things I will touch upon. And similarly, recycling the carbon dioxide from the stationary source, capture it and react chemically. Here, carbon dioxide is a very good reagent. It can be reacted with many other chemicals and converted into various value-added chemicals, and that is another way of recycling the carbon dioxide from the stationary source is also part of this mitigation. And we can get various raw materials, that is fertilizer, one of the key, like urea, ammonium carbonate, etc. we can get. Also, we can convert carbon dioxide into methanol, and also concrete. Okay. And carbon dioxide based concrete like magnesium cement, all these things nowadays, carbon dioxide is reacted. There is our waste material as reacted with carbon dioxide, in which it is proved that it is providing valuable building material, that is carbonated one, which stores the carbon dioxide also in it. Okay. So that all these things leads to a carbon neutrality. Ultimately, nothing possible. We have to go for remove technologies. Okay, that is reduce, reuse, recycle options. Try to attempt. If it is not possible, finally we have to go for a removal of this carbon dioxide, and removal also again we have to go for the natural things. Okay, easiest way, planting trees, grow more trees, and everything carbon dioxide is captured in a natural way, as I told you. But yes, this is a part of the solution. We cannot solve all these things with this alone. We have to go for various means. So definitely, natural way is reforestation. Okay, so this is what top priority should be given, and whatever residue it is fine or managed through other means. And definitely, all these options of circular carbon economy is going to benefit us. A lot of economic benefit because of the reuse option. We are going to get many value-added products. All these things lead to economic growth. And also, because of this business, it's going to create a lot of jobs. Whoever is going to do this recycle, reduce, reuse options definitely will get employment with the value-added products. That's a huge one. So this is what main attempt for this carbon dioxide capture and utilization from the stationary source like thermal power station or cement industry or steel industries. We have to capture the carbon dioxide. About 15%, 10 to 15% of carbon dioxide comes out of this flue gas. And definitely this can be enriched at least 80 to 90% if we have captured this separate from the other gases like nitrogen and other things. Definitely that is the first step in this direction. And already there are various options available, like adsorption is the one, like carbon or other material in which carbon dioxide is captured, adsorbed, and it can be regenerated in a pure form. Similarly, absorption, because carbon dioxide is an acidic gas, you can use some alkaline material like monoethanolamine, a weak base, that can be utilized, and again, on reheating, it will give you out the carbon dioxide in pure form. Okay. And this absorption technique using monoethanolamine is a well-established technique. It is all practiced industrially in many places. The other means of capturing carbon dioxide is cryogenic separation. Going for cooling at a temperature below -20 or so, carbon dioxide will be frozen out, and you can get this carbon dioxide in the liquid form, and that can be used. Okay. This is another option, but it is all sometimes more energy intensive. The other emerging technology I can say is membrane separation. Okay. That's a membrane which is specific to carbon dioxide, will capture, allow carbon dioxide alone to pass through that, whereas the other impurities like nitrogen or something will not be allowed to pass through this membrane. They put carbon dioxide selective things in a very, very small quantity. And relevant to the topic, nanoscale amount of some important materials with soaked on the membrane, that is sufficient to capture carbon dioxide selectively and get almost like a pure carbon dioxide. So these are the various options like adsorption, cryogenic, and membrane to separate carbon dioxide from other impurities from the flue gas stationary source. If we consider the adsorption, there are two ways it is absorbed: by varying the pressure and temperature. By changing the pressure, low pressure and high pressure, you can absorb and desorb carbon dioxide from the absorbed material, absorption medium. Similarly, change of temperature also can do the job. You can, by lowering the temperature, you can absorb carbon dioxide on the solid material. And if you change the temperature, increase the temperature, definitely carbon dioxide will not remain in the pores of the carbon dioxide or the solid material, it will come out in a pure form. So this is one of the options available. But some of this problem is its energy demand is, because we have to change the pressure, lower the pressure, increase the pressure, that requires energy, and about 160 to 180 kilowatts of energy is required to recover 1 ton of carbon dioxide. Okay? With a purity of 85 to 95%, purity of carbon dioxide is possible. The energy demand is very high. So this energy use, again, if we consider, again leads to emission of carbon dioxide. Okay? And nowadays, nanomaterial, the focus of this seminar is also one. You take a carbon, coat with some specific material which is bind carbon dioxide, like imine, a weak base material, nitrogen containing. Organic materials are plenty, like polyethylene amine or gentimer materials can be in trace quantity incorporated to the solid material or membrane material, which has unique carbon selective absorption and allow only carbon dioxide through the solid material or the membrane. So nanotechnology is also play a role, and not very high, small amount put it in a solid adsorbent or with membrane, which is highly selective for carbon dioxide alone. So once this carbon dioxide is separated from the stationary source, it has plenty of uses. Okay. I mentioned about reuse option. That's normally known as technological uses. Right now, that is carbon dioxide can be used directly, carbon dioxide without conversion, no chemical conversion. About 22 metric tons of carbon dioxide currently used per year, like food industry. Okay. Think of our beverages like Coke, Pepsi, all containing carbon dioxide. Right now, what we are doing is carbon dioxide put in from the cylinder. That is actually get from limestone, like a calcium carbonate is heated at about 450 degrees Celsius. Calcium carbonate is broken, calcium oxide and carbon dioxide liberated, and that is what used currently all this. Okay, like food additives, packaging material, because it's a very good cooling agent and the extracting agent, all those things. Industry, it is used, okay, including antibacterial agent, direct use of carbon dioxide. Similarly, all of our, you might have seen fire extinguisher in all the important places, the red color cylinder, that's nothing but for controlling the fire is again composed of carbon dioxide. Even mechanical electronic industry, carbon dioxide is used as a cleaning fluid. Even dry washing, fabric washing, right now we are using PERC, that is chlorinated organic solvent, and that is very highly dangerous. Okay. And this can be used, replaced in future carbon dioxide, that is as a cleaning fluid. All our washing machine in future may be with a supercritical fluid carbon dioxide. This is also important from climate change. One of the aspects of climate change, we are not going to get sufficient rain for two reasons. One is we are going to get more heat and heat wave, rain is reduced. Even rain is there, it is going to be very, very intense. It is recently witnessing very huge extreme rainfall in a single day. 50 centimeter, 90 centimeter are very quite common nowadays. Chennai witnessed 2015, 50 centimeter in a single day. Last year, avalanche in Ooty received nearly 90 centimeter rainfall in a single day. So all these things definitely will lead to water shortage because we don't have the capabilities to store all the water. Everything will be wasted, goes into the sea. And summer also going to be very intensive, more water evaporation, all these things lead to water shortage. So we have to think of technologies in which the washing is going to be made. The main culprit, what is responsible for climate change is carbon dioxide. That is to be used to manage the water shortage. Similarly, air conditioning, CFC can be replaced with the carbon dioxide. And water treatment. Now currently, to neutralize alkaline based water, the pH has to be less than 9.2. And currently we are using sulfuric acid. Instead of this, we can use carbon dioxide, which is again a weak gas and has the ability to neutralize the pH. As I mentioned before, oil industry, okay, to get enhanced oil or enhanced gas like methane, this is what going to be. If we pump carbon dioxide into this oil or gas field, definitely we are going to get more yield. There is extraction of also bio oil from biomass, also carbon dioxide could be utilized. So these are some of the technological uses of carbon dioxide. That is, carbon dioxide is used more or less in a pure form. And reuse. Suppose carbon dioxide converted into some other useful material. Okay. And definitely this is the main scope of carbon dioxide chemistry. Chemistry teaches where in which it can play a large role, converting the carbon dioxide into different value-added products. Okay. Of course, this one summarizes all these things. That is, carbon dioxide can be used as an extractant. Supercritical, I will tell you what is this. Similarly, mineralization, the geologist friends can play a major role, as I told you before. They can capture this carbon dioxide and carbonate them. That is all the silicate material, that is calcium, magnesium silicate material, can be reacted with the carbon dioxide. Maybe they are can be converted to magnesium carbonate or calcium carbonate stored underground, or use it as a building material. Future building material should come from this mineral carbonized material, waste material. Similarly, chemists, they have a huge role as a conversion of this carbon dioxide into value-added products like methanol, methane, urea. Everything is possible, and methane is possible. Methane burning leads to carbon dioxide. We have to reverse the process, which is somewhat difficult to achieve it. And urea is one of the very important fertilizer material which is in huge demand. Methanol, liquid fuel, and methane is again a fuel of future. Suppose this is all achieved, definitely that can be used as a fuel. As I mentioned before, refrigeration, because cooling has the ability, and dry ice. Sometimes ice cream box will come with a dry ice, that is again carbon dioxide. And other miscellaneous applications, and injecting agent, fire suppressor, plastic material, polycarbonate polymers is also going to be part of carbon dioxide based material. Polycarbonate. Now the laboratory, all the earlier what we used is a glass durate. Nowadays we are getting a polymer based one that is nothing but polycarbonate, transparent material that again comes from a carbon dioxide. Okay? And similarly enhanced oil and gas recovery and food industry also. So definitely if you look at the direct use and indirect conversion to value-added products like urea, methane, methanol, all these things is having a lot of scope in solving the climate change problem. So definitely this is one of the key aspects we are going to have in future as a part of mitigating the carbon dioxide. Natural way of green cover is one. The other thing is through direct recycling and reuse of carbon dioxide by converting to various value-added products. Okay. This is again gives a summary of the carbon dioxide as a chemical, drinks, food and fertilizer is one way, and carbon dioxide can be used as a solvent medium, especially in the supercritical fluid extraction as well as pH control, synthetic fuel, oil and gas recovery, and materials and pharmaceutical application. All those things, carbon dioxide is possible through utilization of it, which is going to give a circular carbon economy. So some of the uses, the biologists, especially photosynthesis, common one. Okay, carbon dioxide with a little bit of water and in presence of sunlight and chlorophyll, as carbon dioxide is converted to sugar, and further it is all converted to various things of natural way, one of the biosynthesis process. Okay, so use of naturally occurring material in long type application, which include this carbon dioxide, and using nature, which is better designed. Okay, that may be the most viable means of carbon dioxide, because using natural way also we get variety of different bio trees and other things. Through this we can get different materials by converting carbon dioxide, including fruits or citrus fruits. Citric acid, carbon dioxide is converted into fruits like the citric acid, vitamin C, all these things. It's possible through this photosynthesis by utilizing carbon dioxide. And similarly, microalgae production also, that can be used as a renewable fuel, and also it contains protein and glycerin, many other products. If you go for microalgae, you can get extraction of oil, protein, biodiesel, which is carbon considered as a carbon neutral, as I told you before, glycerin, and all those things is possible by using the atmospheric carbon dioxide through algae, which is a renewable resource. The carbon dioxide and sunlight is going to be available throughout. So carbon dioxide to algae, and this things conversion into all those things is possible even power station may come from in future algae-based one. That is, the carbon dioxide direct through biological route algae is possible to put into this for the biodiesel production. And also seaweed production. Okay? That is also possible in a natural way, again a photosynthesis process. And you can see here about if you harvest about 3.5 tons of algae seaweed, and it contains about 1.27 tons of carbon is present. So much huge amount of carbon is stored in this seaweed production, that is algae biomass. So not only this, if you look at this seaweed, it contains a lot of agar material, alginate, all medicinally important chemical, food material, pharmaceutical and other things can be isolated from the seaweed. That is what one of the biosynthesis way converting the carbon dioxide in a more or less natural way. And some of the countries like Japan, China, Korea, the harvested edible algae material is used as a food material, which is rich in proteins that can be used, the edible material, which is quite common in this countries of Japan, Korea, and China. Also, you can go get some bioplastic material, bioalcohol, biodiesel, everything is possible from the bio-based carbon dioxide synthesis. And not only this, chemical synthesis also possible to convert this carbon dioxide into various chemicals like acetone, isopirin, isoprotealdehyde, malic acid, salicylic acid, one of the important material for aspirin production, and so on. So I will explain one or two few cases because another 15 minutes I have. The physical one aspect of carbon dioxide, as I mentioned before, our future washing machine, all the extraction is going to be based on carbon dioxide. Carbon dioxide at the supercritical fluid condition. Okay. Well, that is at the supercritical fluid is a condition that's a particular temperature and pressure. Carbon dioxide will coexist with gas, liquid, as well as solid forms. All the three forms of carbon dioxide will exist at this particular temperature and pressure for carbon dioxide at this condition, which possess a unique property. Okay? And that is what is going to make this material in future, all the washing machines to remove the dirt, carbon dioxide based on supercritical carbon 1 is the future. Similarly, for extracting all the other unwanted impurities, even for natural material, everything is this one. And if you see the supercritical condition, special properties are reported, and this is similar to nanomaterial. Okay. Nanomaterial, if you compare the bulk material and nanomaterial possesses some super specialty properties. That is what finding a lot of application nowadays at various fields. So similarly, supercritical fluid of carbon dioxide under this particular condition possesses special properties and compared individually carbon dioxide gas or liquid as a solid. One of the main application is caffeine removal from coffee beans is what now presently commercially it is done, and you can isolate caffeine and recover carbon dioxide also later from coffee. Removal from caffeine is one of the important applications right now going on with the supercritical. Future, many more. And coming to carbon dioxide conversion especially is what mainly important, and through which you can get various products out of it. One of the small problem with this, not a small problem, a challenge for this conversion I can say is thermodynamic barriers are there. Carbon dioxide is a very stable compound. Okay? And converting into various chemical is very, very challenging. So we have to think of other possibilities. Okay? That is, it requires a lot of heat to convert it. There is thermochemical with the catalyst is one option, or converting the carbon dioxide into other forms. Okay? homogeneous catalysis also possible, or supercritical fluid condition. The other one is biochemical route, including enzyme route. Okay? Even carboxylase, that is carbon dioxide based enzymes also available, through which also we can convert the carbon dioxide into various other material. And natural way through solar, or solar in combination with the thermal and photocatalytic route is another option in which carbon dioxide can be converted into the valuable materials like methanol or methane, and also photochemical and catalytic route. So thermal, which is energy intensive, if you are going for thermal, definitely catalyst should be employed. Okay? Then only the conversion is feasible. Otherwise, you have to spend again huge energy. Otherwise, the energy should come from a renewable one like solar or wind. So the best way of converting carbon dioxide is through bioroute enzyme or photochemical. The photochemical also energy should come from natural way using sunlight, or the energy should be derived from solar energy. And electrochemical also is going to play a major role. Again, to drive the electrochemical, it should be solar driven. With this, we can minimize the energy demand or the thermodynamic barrier in converting the carbon dioxide into anything. And if you look at some of the applications of carbon dioxide, direct application, converting carbon dioxide into urea, already about 80 metric tons of urea is generated by reacting carbon dioxide annually. Methanol production is also happening. It is existing. About 2 metric tons of methanol is currently produced per year. This should be increased. And cyclic carbonate, 0.04 metric ton, and salicylic acid about 0.025 metric tons of salicylic is also produced. It's all commercially going on, existing, in which carbon dioxide is utilized. Sometimes not directly from this stationary source. It's all derived in the pure form. That should be stopped. And this carbon dioxide, whatever goes into this product, should come from a renewable one that's from the stationary source. And some of the emerging area in which carbon dioxide utilized is carbon dioxide based polymer, dry reforming, and carbon dioxide hydrogenation to form formic acid. Reduction of carbon dioxide, we will get formic acid. Again, fuels like dimethyl and ether and intermediate compounds are used. These are all emerging. Shortly, they will come to this like existing one. And there are few options. The laboratory scale, it is all there, like isocyanate formation for carbon dioxide, organic carbonate, lactose synthesis, carboxylic acid, and many more is coming up. And these are all in the exploratory level, and some of you can take interest in this and add more list of compounds to this. So this is again some of the things already what I have shown earlier, and with the catalyst and without catalyst also happening these synthesis of all this material. Dimethyl carbonate is one of the important material in which it acts as a carbonating agent as well as methylating agent also in certain organic synthesis to provide methylating group as well as carbonate group. Right now, this dimethyl carbonate is produced by a toxic route, that is a phosgene route. This is reacted with methanol to produce a dimethyl carbonate, and currently the reagent used is toxic in nature. Phosgene is a toxic chemical. And currently, many chemists, they have invented other alternate routes, which is benign as a part of the green chemistry concept, which is enormously friendly. They use catalyst material like zirconium oxide or combination of zirconium oxide with the cerium oxide. They directly reacted carbon dioxide with methanol to get this dimethyl carbonate. So the use of this dimethyl carbonate, it is acting as a polycarbonate material, polyurethane, added to gasoline to increase the octane rate, octane number, etc., is some of the application of this dimethyl carbonate. So here again, huge potential of direct reaction of carbon dioxide in presence of heat. Catalyst is possible. And this is another type of dimethyl. When also possible through change of catalyst, you can get higher homologous compound similar to dimethyl carbonate. Another important reaction, it's all school chemistry. An important valuable product is obtained, that is aspirin synthesis. Phenol in alkaline medium is reacted with the carbon dioxide to get salicylic acid, which is again acetylated to get this aspirin drug. Okay. So direct reaction of carbon dioxide with the phenol is an important thing. That is proceed as per the post-Schmidt reaction. This is again one of the important things in which carbon dioxide is reacted with the phenol to get the aspirin molecule. Also, cyclic carbonate. I'm giving a few examples in which, in presence of magnesium oxide acts as a catalyst, thus can be reacted directly with the carbon dioxide to get a cyclic carbonate material. And there are many more carbonate material, including glycerol, can be reacted with the carbon dioxide to get glycerol carbonate is also possible. And very important application, as I told you in the beginning, urea synthesis. Carbon dioxide reacted with ammonia initially forms ammonium carbamate, which on dehydration yields urea. It's a much demanding fertilizer. So this is one of the important applications. And if possible, the ammonia also comes from some environmentally benign route or environmental route. Carbon dioxide can be reacted and converted into ammonium carbamate, and subsequent reaction, dehydration, simple dehydration at high temperature gives the urea, and which contains about 40% of nitrogen available in the soil. So these are some of the very, very important applications in which carbon dioxide can be converted into the useful raw material. So to conclude, the carbon dioxide and other greenhouse gases poses a large risk to whatever the present climate what we change. It is getting changed already, started thing, and we face a lot of issues. Okay? So we have to pay attention to avoid the risk to the society or our planet, so that our future generation also, what we are enjoying reasonably, comfortably, that should not be a crisis later on. That should be avoided. Okay? So in that way, we have to contribute in mitigating this climate change. Because if we look at it, burning of fossil fuels is not going to end very soon. Another 30 to 40 years, it is going to be there. Carbon dioxide emission also going to be there to get energy. Okay? Definitely, as we discussed during this talk, the carbon dioxide capture and utilization, okay, through biological means or chemical route, everything is definitely part of the solution in mitigating the carbon dioxide, and which also focus on circular carbon economy. Okay, which is all aimed, that is drawn from the based from this stationary source, that is the carbon dioxide, into a valuable asset for society. Urea is a much demanding chemical. So definitely, similarly, other carbonate, everything is useful things. So society is going to be benefited because of this utilization. Okay? And the equivalent to decarbonization, the energy sector, whatever we remove carbon dioxide, use it, all those things, okay, is a transition to renewable energy carbon in the chemical and plastic industry. Okay. So definitely in the energy sector, carbon dioxide, if you decarbonize it in converting into a chemical and a polymer or plastic material, definitely. And this carbon, what we consider as a waste carbon dioxide, is going to be a renewable one in the form of circular carbon economy. And chemists and other geologists, botanists are having a huge role to play in the future. So definitely there are challenges in utilizing carbon dioxide, it is all not very easy. But challenges are the opportunity for everyone to convert it and make this carbon dioxide into useful material. So with this, thank you all the participants for your patient listening. If there are any questions, I'll be happy to answer.
Good evening, sir. This is Preeta. There are a few questions in the chat box. Shall I proceed, sir?
Yes, please.
Yes, sir. There is a question from Dr. Srinivasan V.
Okay.
I think there may be enormous reduction in carbon dioxide in this situation. Will there be increase in rainfall and lowering of earth temperature in the coming days?
Can you repeat the question again? I'm not able to understand few aspects of it. Can you repeat?
I think there may be enormous reduction in carbon dioxide in this situation. Will there be increase in rainfall and lowering of earth temperature in the coming days?
Definitely it is possible. If it is achieved globally by all, not only India and few countries are attempting in mitigating the carbon dioxide, it is not possible. Because atmosphere is an open system, and definitely it is going to be a challenge, not easy. Everybody, if they are putting effort and minimizing the carbon dioxide, so the renewable energy, and also going for increasing the green cover, definitely, because green cover is going to lower the temperature and bring a lot of rain, that is possible. Definitely, but you want to stop emitting carbon dioxide. You want to switch over to other renewable sources or capture carbon dioxide and sequester or utilize it. Definitely, it is possible. In future, the temperature is we can keep it below 2 degrees Celsius rise as a requirement now. All countries, they have committed their own NDC, that is nationally determined contribution. India is also there, and other countries, everybody should attempt, then it's possible. Otherwise, difficult.
Thank you, sir.
Thank you.
There is one more question from Bharati ma'am.
Yeah.
Is it possible to separate the carbon and oxygen from CO2 as is possible with other molecules?
Yes, definitely possible. Even carbon dioxide can be converted into diamond. There are already few Chinese scientists, they have reported this. Even graphite is possible. But the temperature requirement is very, very huge. Nearly 4,000 degrees Celsius would rise the temperature. Okay? Then it is possible. So if you look at carbon dioxide, the energy requirement, heating it 4,000 degrees Celsius is a big challenge, very energy intensive, but theoretically, yes, it is possible. Even carbon dioxide can be converted into diamond and graphite.
Thank you, sir. The next question is from Sridharan Yam.
Yeah.
Shall I proceed, sir?
Yes.
Sir, can you explain the concept of methanol economy?
Methanol economy.
Yes, sir. Methanol economy.
Right. See, carbon dioxide, whatever produced now, is a natural way. It goes, and methanol also naturally. But if you see this carbon dioxide, there is a possibility carbon dioxide can be converted into methanol. So there are two routes right now available. One is electrochemical route, the other one is photochemical route. Carbon dioxide, if you pass hydrogen and it is getting reduced, and electrochemically, if it is the cathode route, even hydrogen is produced. The produced hydrogen is used to get methanol, okay? Reasonable quantity. But based on whatever the available literature, the yield is not very great. Okay? All milligram or small quantity. So a lot of scope is there to improve the yield. Even methane also same thing. Because if you see the reduction process, carbon dioxide to carbon monoxide, and then to formic acid to methanol, methanol to methane. That is how the reduction proceeds. And definitely economy, it is possible. Somebody is going to achieve a still better yield. Right now the yield is very, very low. And definitely if you want to compare the economy, difficult. with the current process of manufacturing methanol and this carbon dioxide based growth difficult. Low. We cannot compare the economy right now.
Thank you, sir. The last question, sir. Shall I proceed, sir?
Yes, please.
CFC is also responsible for global warming. In what way, by altering its usage with carbon dioxide, helps to reduce global warming?
No. Please repeat the question. The first part, I am not able to.
CFC, chlorofluorocarbon, is also responsible for global warming.
Yes.
In what way, by altering its usage with carbon dioxide, helps to reduce global warming?
See, not only CFC, any compound put into atmosphere is responsible, except maybe perhaps the homonuclear molecules like nitrogen. Okay, any compound with a dipole moment or induced dipole moment will have the ability to absorb the sunlight, that is especially the IR part, and convert this into heat energy. That is a basic concept of global warming. Definitely, if we minimize CFC, it is already, as per the Montreal Protocol, it is already happening. CFC, we should not use it for any purpose. It is banned. So already it is taken care of. Okay, so you cannot make CFC. CFC is also one of the culprit. So because of this, not only this carbon dioxide related global warming, CFC, the other major impact is the ozone layer depletion. It reacts with the ozone through photochemical route again. Whatever the chlorine generated in the stratosphere destroys the ozone in the stratosphere, which is the another different things. Okay? So carbon dioxide is another one which is directly affects or causes global warming. Whereas CFC, the problem almost all countries stopped CFC using for refrigeration or any other cooling purpose, but it has a dual problem, not only contributing towards global warming, the other aspects of ozone layer depletion also is an issue with respect to CFC compounds.
Thank you, sir. One more last question,
Yeah,
sir.
please.
Does temperature affect carbon dioxide levels?
Temperature affects carbon dioxide level. I am not able to understand the question. What way it is referred, I don't know. But naturally, if you consider 1 or 2 degree rise may not affect the carbon dioxide influence. Okay? Suppose the carbon dioxide is going to be there in huge quantity also later, yes, possible. Because if you see the biosynthesis, the tree plantation or rice cultivation, everything, what we discussed, suppose another 1 or 2 degree rise may not affect much. Okay, especially Europe, it is considered beneficial. Temperature increase, they have reported more yield, whatever compared to this, and they absorbed because of the change in temperature, they are getting increased yield. But all this biological system is able to tolerate the temperature to certain degree. Okay, up to 1 degree or 1.5 is fine. Suppose it goes beyond, definitely it is the ecosystem. Definitely the natural ecosystem will be affected. Carbon dioxide may not be affected directly, but definitely in the nature. Did I answer the question correctly? Understood the question and the answer to you? I don't know. Because the question was, well, increase in temperature affects carbon dioxide. That I doubt it may not. 1 or 2 degree rise will not affect. But definitely the increase in carbon dioxide will increase the temperature. That will affect our natural ecosystem.
Thank you, sir. Thank you so much, sir. Now I hand over to Stanley, sir. All the
So
questions
that's all?
are over. Yes, sir. Yes, sir. All the questions are over.
Thank you.
Stanley, sir, please.
Yeah, there is no, if there is no more question from the participant side, we can wind up the session. And if any participants want to have some interaction with the professor, you can ask 1 or 2 questions. Otherwise, let me conclude the session. Participants, if you want to ask any question directly to the Professor Palaivelu sir, you can ask. Right. So if there is no question, sir, I want to thank you for giving us such a nice and wonderful presentation on carbon dioxide utilization for climate change mitigation. We were able to learn so many new things. You have explained everything very clearly. You have explained what are the problems associated with carbon dioxide and how to overcome all those problems. It was very informative and very useful for all the participants, sir. In spite of your hectic and busy schedule, you gave us the time for this wonderful session, sir. Once again, I thank you on my department behalf as well as on behalf of Venkateswara College of Engineering, sir. We want to have more sessions like this with you in future also, sir. Thanks for accepting our invitation, sir. Very kind of you. And if you want to say something to the participants and conclude, you can say a few words to the participants, sir.
So thank you, Dr. Stanley, for the opportunity. It was really a wonderful thing in talking to you. Even yesterday also informally that I appreciate how you have to take off, that you gave the tone yesterday itself.
Yes, sir.
So that itself a different thing I noticed, because other organizer only 5 minutes, 10 minutes before, but you made me 1 day in advance, so that you are seeing everything is going smoothly. So that way I congratulate you.
Thank you, sir. It's a teamwork, sir. As a team, we are working very hard, and all the credit goes to my team only, sir. My team and head of the department.
Even yesterday I noticed your team.
Yeah, actually, we are from different places. And, a few from Chennai, and the rest are from other places of Tamil Nadu. So, in spite of that, we are able to organize this. And we are really very happy to see your beautiful and smiling face, sir. Most of the time, you are smiling, and it gives us so much courage. Thanks for
Thank you
accepting our invitation.
So
thank you, sir.
Thank you.
Yeah, if you
organization for the opportunity in future. Also, I would like to associate, and any participants, whatever I talk to you about this one, you can approach me if you have any questions. You can email me or contact me through phone. So the most of them are our Anna University affiliated teachers, is it not? Or any other organization.
Right.
Mostly everybody from Anna University, they can approach, even others also, no issue at all. They can write to me. And the first slide, I have given my email address, they can write to me. So thank you for the opportunity once again.
Yeah, thank you, sir. Thank you, sir.
Thank you.
Right, sir.
Thank you, sir.
If you wish, you can leave the meeting, sir. If you have any work, you can leave the meeting, sir. And
Thank you.
Participants, we have posted the feedback again and again a number of times in the chat box. Make use of the feedback link for posting your feedback. We will be here for another 15 to 20 minutes. So if you find any difficulty in posting your feedback, please let us know through the WhatsApp group, or you have our mail ID. You can just contact us. Pardon?
பாலுசாமி ஏதோ சொல்றாரு.
பாலு என்ன சொன்னீங்க?
Nothing sir,
என்ன சொன்னீங்க? கேக்கல.
Nothing sir.
ஓ, நத்திங் தான் அவ்வளவு வேகமா சொன்னீங்களா? ரைட்.
குழந்தை ஓடி வந்து ஒரு இடத்துல.
சரி.
நான் உட்கார்ந்துட்டு இருந்தேன்.
ஓகே.
அதுக்கு தான் சத்தம் போட்டேன்.
நம்ம போன்ல பேசிக்கலாம்.
இல்ல பரவாயில்ல. அதெல்லாம் அதனால ஒண்ணு இல்ல. No problem.
So participants, if you find any difficulty in posting the feedback, we are here to help you.
இல்ல அது சொல்லல. ஹெவி ரெயின்லயும் செஷன்.
ஆமா சார், ஒரு முறை யூடியூப் லிங்க் மாத்திரம் போச்சு. அதனால மறுபடி அந்த இங்க வீட்ல பவர் ஃபிளக்சுவேஷன் அதெல்லாம் வந்துச்சு. கரண்ட் போயிட்டு வந்ததுனால யூடியூப் மறுபடி ஒரு தடவை நான் ரெஃப்ரெஷ் பண்ணி புது லிங்க் கொடுத்து again people are still watching, sir. ஆனந்த் கரெக்டா கமெண்ட் பண்ணிட்டே இருந்தாரு. முடியற டைம்ல நிறைய பீப்புள் உள்ள வராங்க.
ஆனந்த் கமெண்ட் பண்ணல, ஸ்ரீதரன் கமெண்ட் பண்ணிட்டாரு.
அவரும் பண்ணாரு
சார், கமெண்ட் பண்ணாரு. அத தான் காப்பி பண்ணி போட்டேன்.
அப்படியா?
வேற ஒருத்தர் பண்ணாங்க.
ஆஹா. இல்ல ஆனந்த் போடுறப்போ அது வந்துச்சு, அந்த ஸ்மைலியோட வந்து நான் பார்த்தேன்.
அததான் நான் திரும்ப போட்டு சொன்னேன்.
ரைட் ரைட் ரைட். சோ இது
இப்ப கூட பாருங்க, யுவராஜ் ஜி அப்படின்றவரு அட்மிட் பண்ணதுக்கு வெயிட் பண்ணிட்டு இருக்காரு. கொடுக்கவா என்னன்னே தெரியல.
கொடுங்க
நிறைய பேரு.
சரி விட்டுருங்க,
உள்ள ஒரு வாரம் கேட்டுக்கோங்க.
சார் மழை அப்படிங்கறாங்க, கனெக்டிவிட்டி இஷ்யூங்கறாங்க, நம்ம வேற ஒண்ணும் சொல்ல முடிய மாட்டேங்குது. ஈவன் ஐ ஃபேஸ் த சேம் டிஃபிகல்ட்டி. எனக்கு ஒரு செகண்ட் கரண்ட் போயிட்டு மறுபடியும் வந்துச்சு. சார் ஃபீட்பேக் இஸ் நாட் வர்க்கிங் ஃபார் மீ போடுறாங்க ஜெகதீஸ்வரி. மேடம் once again you please try madam, once again you try the link.
நெட்வொர்க் ப்ராப்ளம் அவங்களே போட்டுட்டாங்க.
ஓ ரைட்.
சோ வேற
லேட் பண்ணி க்ளோஸ் பண்ணலாம் சார், உடனே க்ளோஸ் பண்ண வேண்டாம்.
Still there are 53 people. ஆனந்த் எவ்வளவு பேர் இருக்காங்க? 53 ஆ 45 ஆ? 45 more ன்னு ஒன்னு காமிக்கு, 52 காமிக்கு.
52 சார்.
52 காமிக்கு சார்.
ஆமா, ஆனா சைடுல ஒண்ணுல சசிகலா and 45 more அப்படினு காமிக்குது ஸ்கிரீன்ல.
அது சார் இன்னும் பிரசன்டேஷன்ல இருக்காங்களா?
சார் he has left I think. சாரோடது தெரியல.
நான் இருக்கேன்.
இல்ல நான் பழனிவேல் சார் கேக்குறாங்க.
அவர் ஸ்கிரீன் ஒருவேளை வந்துச்சுன்னா வரலாம்.
நான் கிரிட் வியூ போட்டிருக்கேன், அதனால நிறைய பார்ட்டிசிபென்ட்ஸ் still they are in the line.
Forty-four ஸ்டாண்ட் சார். 42 தான் இருக்காங்க.
ஆமா இப்போ 42. Participants who have given the feedback, can you please leave the meeting so that we can identify how many people are yet to complete the feedback procedure. Please cooperate with us. If you have posted the feedback, you can leave the meeting so that we can help others. Sir, HOD sir, இன்னைக்கு ட்ரையல் மீட் வேண்டாம்னு பிஜு சார் சொல்லிட்டாங்க.
சார் ரைட், நோ ப்ராப்ளம். அப்போ ஒண்ணே தான் இருக்கு.
ஆமா, நாளைக்கு 3:45 க்கு நான் ஜாயின் பண்ணிக்கிறேன்னு பிஜு சார் சொல்லிட்டாரு. அதனால இன்னைக்கு we don't have a trial meet.
ஓகே சார்.
ஓகே சார்.
ட்ரையல் ஓகே, அவரு சாரே சொல்லிட்டாருன்னா ஓகே, நம்ம அதுல
25ல நம்ம எத்தனை பேர் இருப்போம் சார்? நம்ம இதுல போகணும்னா கிளம்பலாம். பிரீதா மேடம் யூ கேன் லீவ், நீங்க விரும்புனீங்கன்னா போலாம். நாச்சியப்பன், திருமலை.
ஓகே சார், நான் உங்களுக்கு கால் பண்றேன் சார்.
ஓகே. பாலுசாமி.
Thank you sir.
Others 19 சார்.
So
19 18.
எஸ் சார். நீங்க கிளம்புனா கிளம்பலாம். ஹெச்ஓடி சார்லாம் கிளம்புனா கிளம்பலாம். நாங்க இன்னும் கொஞ்ச நேரம் இருந்துட்டு we will Bhaskar sir, you can also leave.
Okay sir.
No, I'm not forcing anyone. If you wish you can leave.
Yeah, sure sir.
ஏப்பா கோஆர்டினேட்டரே போய்ட்டா என்னப்பா இப்படி பண்றது? அப்புறம் என்ன பேசுவீங்க நீங்க?
சார் நாங்க இருக்கறோம் சார், ரெண்டு பேர் இருந்து பாத்துக்கறோம் சார்.
ஓ, அது ஃபீட்பேக்
சொல்றாரு, வேற எதுவும் இல்ல. இங்க
ஃபீட்பேக் மாத்திரம் தானே, நாங்க மாத்திரம் ரெண்டு பேர் பாத்துக்கறோம், கடைசி வரைக்கும் இருந்து பாத்துக்கறோம்.
இப்போ ஃபீட்பேக் போடும்போது மீட்டிங் உள்ள இருக்கணுமா தேவையில்லையா?
மீட்டிங் உள்ள இருந்தா சார் போடுவாங்க.
லிங்க் உங்ககிட்ட இருந்துச்சுன்னா நீங்க போடலாம்.
ஆமா, ஃபீட்பேக்ல
லிங்க்
சாட் பாக்ஸ்ல இருக்க லிங்க் கிளிக் பண்ண உடனே அது வெளிய போய்டும்.
சரி.
சாட் பாக்ஸ்ல இருந்து கிளிக் பண்ண உடனே அது நெட்ல தூக்கிட்டு போய்டும் சார். அப்போ நீங்க மீட்டிங்ல இருக்கணும்ங்கற அவசியம் இல்ல, நீங்க இன்டர்நெட்ல நீங்க கொடுப்பீங்க.
ஓகே. அதான் கேட்டேன், வேற ஒண்ணு. இல்லை ஏன்னா நிறைய பார்ட்டிசிபெண்ட்டுக்கு ஃபீட்பேக் ஓப்பன் பண்ணிட்டும் இதுலேயே இருப்பாங்க, அதனால
ஆமா சார், அது நிறைய பேர் இருப்பாங்க தான், ஒரு 5-6 பேர் அந்த மாதிரி இருப்பாங்க.
20
நிறைய
people
பேருக்கு டவுட்
இருக்காங்க.
சார் சிவகுமார் சார் ஒரு கேட்டிருக்காரு, டுமாரோ செஷன் பிளேஸ்னு சொல்லியிருக்காரு.
இல்ல சேம் லிங்க் will be used for all 7 days னு நம்ம சொல்லிருந்தோம். So they can use the same link, and moreover we will put the same link in the WhatsApp group also. So just follow the WhatsApp group, sir. You will find the same link, but you will have a different YouTube link. YouTube link will be different.
Same time.
Same time.
Speaker only is Dr. VM Biju from NIT Trichy.
Thank you, Sivakumar sir. Sir, you are from which institute, sir, Sivakumar sir? Anil Patel, are you there? Anjali Singh, Satya Narayana B, Kim Manisha, Dr. N. Shruti, Meera K.S., Dr. Matilda Madam, Mohana Priya, Munawar Sultana, Shrishapa,
application updated.
சார் நான் யூடியூப் லைவ் நான் எண்ட் பண்ணிடுறேன் சார்.
ஓகே சார், ப்ளீஸ் பண்ணிடுங்க.